Hey, I'm going to explain loops to you. Um, let's just make a new file, loops.py, and open it with any text editor you want. So basically, a loop is used when you want to do something very repetitive. Let's say we want to do something 5 times, so we can use a for loop. In Python, we have a for in loop and we have a while loop. There's no traditional C style for and then you initialize your variable. Yeah, for int I equals 0, I is less than 10 I plus plus. The style of loops doesn't really exist in Python. So yeah, in Python we use something for, and then we can say I in range. Okay, what I'm doing here is I'm saying for, then we have a dummy variable called I. Now this is going to take on a value in something. Yeah, range is a function that returns a collection of numbers from 0 to 1 less than whatever you put in here. Range 5 will give you the numbers 0, 1, 2, 3, 4. This is always excluded, whatever this is. Anyways, so I have R taking on a value from 0 and then 1 and then 2 and then 3 and 4. So if we print I over here, so every time it'll assign I a value in here. So it'll start off at 0, it'll begin going through this function, this loop body, and it'll print out the current value of I over here. We can also print out I squared if we want to, so that's fine. Now this whole thing, yeah, as long as it's indented one level, Python will take it as the loop body. So it'll start off at 0, printing 0, then 0 squared, and then 1, 1 squared, 2, 2 squared, 3, 3 squared, 4, 4 squared. But now at 1 go to 5 because 5 is exclusive, and range is a function that just returns an iterable that has these numbers 0 to 4, and the step is 1 by default. Just now I'll explain how to choose the starting value in the range and the stopping exclusive value and the step. But for now, this is all we really need. Let's just print that out. So Python loops.py, and you can see 0, 0 squared, 1, 1 squared, 2, 2 squared, 3, 3 squared, 4, 4 squared. And yeah, that'll work there. But now let's say we wanted to start off with 1. Okay, we can choose a starting value 1, put a comma, next argument to the range would be the stopping value, which is exclusive. So let's say we want to go all the way up to 100, right? And now let's say we wanted to have a step of 2. By default this is a 1. If you leave this out, it'll be the same as having it like this, because Python has default values for its function. So by default the step is 1, but we'll use a step of 2 here. So now I'm not actually going to list all the values of I here, because it'll just, well, I can do this. It's going to start off at 1, the step is 2, so then it'll be 3, and then it'll be 5, and then 7, and then 9, and then a whole lot of other values, and then these are odd numbers, so it'll get up to 99 actually. Yeah, should get up to 99, I suppose. Yeah, it'll always be 1, 3, 5, 7, 9, 11, 13, so it's always going to have the second digit as a 1, a 3, a 5, a 7, or a 9, and all the way up to 99, and it'll stop at 99. So we can just run that now. Let's clear the screen, run that, and you can see 1, 1 squared, 3, 3 squared, 5, 5 squared, 7, 7 squared, all the way up to 99, then 99 squared. So yeah, that's the for in loop. That's all you really need. You can change the step sizes. This I doesn't actually have to be I, it can be anything. You can call it some long variable, whatever, some long variable name, and then we can print some long variable name and some long variable name squared. That'll do the exact same thing. Your variable names don't really matter, besides well, obviously for readability you'll want descriptive variable names, but obviously if it's too long it'll be a bit annoying to code, but as you can see that's exactly the same. So yeah, you can choose whatever name you want, and this just takes on any value in this range, which is just going to give you a nice collection of numbers based on whatever you give it here, starting off with the 1, stopping at 100 exclusive, and incrementing by 2 every time. Another type of for loop we can, well, it's actually the exact same for loop, but we can also take on characters in a string. So let's say we had some string called name, which is equal to I don't know, potato. Name is equal to potato. Now we can say for char in potato, for char in name, for each character in the string potato, which is stored in name. Right? We can call this anything we want to. I'm just going to call it char because I just want to make it more explicit that it's a character. But yeah, we can just print char. Now it'll just print each character of name or each character of potato on a new line. And let's just run that, or clear this, run that. Okay, so it's done all of the previous stuff. Now it's printed each character of potato on a new line. With the print function, I don't think I actually explained this earlier, but you can also specify what character the end should be. So by default it puts a new line at the end. So if we put a comma and give it another argument, we say end equals. When you're working with when you're calling functions, you can specify arguments explicitly by writing the name followed by an equal sign and then whatever you want the end to be. So end equals, let's make it a space. By default this is a new line, but we're going to make it a space. So now every time it goes through this loop, char will take on the first character, it'll print char, and then the end of the it won't have a new line, it'll just put a space of that, goes to the next character in name, and then the second character, it'll print that out, follow that by a space, and then that'll just happen, and then we'll actually have an extra space at the end over here, but that's fine. Let's just run that, and you can see potato, and then there was no new line, so you can see that my terminal's prompt here is actually straight off that. I'm just going to push enter, so that's fixed. So yeah, that's another thing I haven't explained, but now I've explained that. And we can also make while loops, because for loops, you usually use a for loop when you know when you are going to stop the loop. Like you know you're going to stop when some long variable name is equal to 100 basically. And yeah, we know that we're going to stop when we run out of characters in name. But now with the while loop, you don't really know when you're going to stop it. So let's say we wanted to find the sum of the first 100 numbers. We can say total is equal to 0, and now we want to, well, actually not the sum of first 100 numbers. We want to find the sum of how many first numbers. Okay, I'm not stating this very nicely, but let's say we want to add the first n numbers. We want to find the n such that the sum of the first n numbers will give you 200 or less, well, 200 or more. So as soon as the sum gets above 200, we want to stop. So that's just some random example I thought of. So while total is less than 200. So once total is greater than or equal to 200, we're going to stop. Then we'll say total plus equals. Now we need some number here. So let's actually initialize a number. So we'll call it current number and set it to 1. So while total is less than 200, we'll add the current number. So total plus equals current number. And oh, actually, plus equals is just shorthand for this. Well, in this case, total is equal to total plus current number. These are equivalent, where it evaluates whatever total currently is equal to, it'll add it to current number, and now it'll assign whatever that result is to total. The right hand side always gets evaluated before the left hand side gets assigned. Yeah. So total will get incremented by current number. And then now we have to remember to increment current number after that. It's current number plus equals 1. So now current number will be 2 after the current number is 1. After the first iteration of this loop's body over here, this whole body over here. So current number will then be 2, it'll add that to the total, and then increment current number again and again. Now, total will eventually be greater than or equal to 200. So when that happens, this loop is actually going to, well, this will not get executed, and the Python will carry on execution after that. So we can say the sum of the first, and now the number of numbers we used was current number. Yeah, current number. Actually, let's see. Total plus equals current number plus equals 1. So we're actually incrementing current number by 1 after incrementing total. So actually we will want to say, we want to go 1 back from current number because we've incremented it, but now total only, the last time we added something to current number, we added 1 less to it. So we should actually say the sum of the first, then current number minus 1, and then numbers is, and then now we can have the actual sum, which is total. And now this is the first sum of the first n numbers that will be greater than or equal to 200, because we want the sum to be as close to 200 as possible, but not below it. It must be 200 or above it. So that's what this will give us. So it could be 200, might be 201, 202, something there, but there would be no sum that's less than it that this would print out. So let's just see what that gives us. Let's clear the screen and run that. So the sum of the first 20 numbers is 210, because yeah, if we subtract the 20, the number before this would have been 190. Well, the sum before this would have been 190, the sum of the first 90 numbers, and then the next number was 20. We added 20 to 190 and we got to 210. As soon as that got to greater than or equal to 210 or 200, it stopped, which is what we got here, while the total is less than 200. So that's why it actually stopped executing, and the very first sum we had after the total got to 200 or above it was 210. And we could even see what the last number was by checking current number minus 1. So that's how while loops work. And yeah, that's about it for the loops. You can, with the for loops, you can have ranges, you can iterate over strings, you can even iterate over lists. And lists are actually pretty easy. Let me just explain that to you now actually. So even though I've called this loops, I'll just rename it to loops and lists just now. But let's just say list 1. To make a list, you just have to assign. You don't actually have to assign it to a variable. You can use them straight in expressions, but I'm just going to say list 1 is equal to. Now, if we have a pair of square brackets, that indicates a list here. Right now, this is an empty list with nothing in it, but we can have 1, we can have 5 in it, we can have 2 in it, we can have some string in it, like called something, and then we can have 3.14159. A list in Python can just have any types of values in them. They don't all have to be the same type, like if you've coded in C++ or C or or in Java even, most of the time they want you to only use uh, value in here. Like if they must all be strings, you can't have a mixture of strings and ints. But now in Python you can really just mix up anything you want because well, Python's a lot nicer for this kind of stuff. So that's how you make a list. It's pretty easy. And now for thing in list one, you can really just use any dummy variable you want. For each thing in list one, we want to print out whatever that thing is. And now this will just print out 152 something 3.14159 all on a new line. So let's just run that or clear this. Run that. Then you can see it actually did that 152 something 3.14159. So that's really how lists work. Well, if you want to loop through a list, you can, like that. And I'm actually going to make a new file for the list, really. This is just, yeah, this is just the for loop part of a list. Let me show you how to actually add stuff to a list dynamically now. So let's create a new file, text file, lists.py. Okay, now let's open that with Kate. So let's say we have list 1 is equal to an empty list. Just zoom in, yeah. List 1 is equal to some empty list. Now let's say we want to put odd numbers into this list. We can say for I in range, now odd numbers, and we want the odd numbers from 1 to 27. Okay, so we'll start off at 1. We want to go up to 27, so we'll put a 28 here. And we should have a step of 2, so we can skip the even numbers. So it'll start off at 1, 3, 5, 7, all the way up until 27. Once it goes to 29, it's above the stopping value, and that means it'll stop. So we can just say list1 dot append. Now what we want to append to list 1 as an add to list 1, we want to append I. So this will just loop through each value in this range from 1 to 28 exclusive with a step of 2. It'll append each value of I, which is just basically all the odd numbers from 1 to 27. Now this list will get full of those values. So now we can literally just print out list 1, which will show it with square brackets and everything. So let's just do that. So clear the screen here. Zoom in a bit. Okay. Let's run that. Python lists.py. And you can see we got all the odd numbers from 1 to 27 printed out as a list. And we can also just say for odd in list 1 print odd. This will just print out each of those things in the list, each of those odd numbers in the list on a new line. So if we do that, it will print out the list like in this normal format as you'd see in Python, and then on each line it'll just print the actual odd numbers without the square brackets or anything. It will just print out for each value. And we can also do other stuff, yeah, like let's say we wanted to find the minimum in this list. We could say print the smallest odd number from the smallest odd number between 1 and 27, well, inclusive of both obviously, is, and then we can use, obviously it's 1, but we'll use a function for that called min. Min will give you the smallest number given some kind of iterable or some kind of list which you can iterate over. So the min of list 1, min will just return a single value which is the smallest value it can find in list 1. It compares it using the less than or equal to operator, but you don't really have to worry about that. Just know that min just works on any kind of collection and gives you the smallest. You can also try to implement your own one if you want, but I'll show you how to make functions later. For now, this should just give you, well, it'll print out whatever the smallest number is, which we know is 1. So let's just run that again. And there it is. The smallest odd number between 1 and 27 is 1. If you want, you can get the largest as well. Largest odd number between 1 and 27 is, then you just use the max function. Max will give you the maximum number in the list 1. And do that, and you can see 27. So that's just about it, I think. Thanks for watching. Please like and subscribe to this video if you enjoyed this.